In Pakistan, 144 million people do not have access to reliable electricity with frequent rolling blackouts. There is an abundance of irrigation canals in the Peshawar region, with most having between 0.5 and 2.5 metre head range. We believe that by designing a low-head hydropower converter, we can harness this clean resource to provide reliable electricity. There are no commercial products available that can be used, so the aim of this project is to design a solution to this problem. This project could also be adapted to other irrigation canals all around the world. We based our design on an undershot water wheel because it maximises the height difference of the water. A ski jump was used to direct all the flow into the blades, with a gap between them to allow debris to pass through. The ski jump can also be lowered fully to allow water to still pass through in case of wheel malfunction. This is an innovative solution to the problem. Our innovations come in 4 parts. Firstly, we created a scaled model of the design of the ski jump and water wheel to gather performance data and to test the functionality of the design. A hydraulic system was designed as a scaled version of the specific site in Peshawar. The model has a head difference of 0.6 metres and a flow volume of 0.014, as can be seen in the picture on the screen. Secondly, the external metal frame of the water wheel was innovated to withstand higher stresses and allows the central axis to be removed completely, saving material and weight. Also, we analysed and optimised the geometry and the number of blades of the wheel so the inflow vector would be parallel to the blade shape to minimise losses during the transfer of energy. At full scale, the hydro wheel is too slow for a generator, so gearing is needed to match the speeds. For a conventional power takeoff setup, an axial gearbox accounts for around 40% of the installation costs. Our solution uses friction rollers, which increases the power takeoff speed by a factor of 10, reducing gearbox requirements. Railway theory was utilised to improve friction and stability between the wheel and rollers. Both parts were made from aluminium to reduce wear and increase friction. The rollers and outer rim of the wheel were altered to mimic a train wheel and track to improve stability during rotation. With the wheel and roller design sent off to be manufactured, we started building the hydraulics rig and blades of the wheel. When the hydraulics rig was fully assembled with the pump system, the ski jump was then added. The support structure was also erected at the same time, supporting all elements of the wheel and power takeoff system. The position of the centre of the wheel and the rollers to the ski jump was established using theory and graphical software. We could then begin to test the wheel. The interaction between the water jet and the blades shows the effectiveness of the geometry. Based on the model scale, we designed the full-scale device for this site. We expect the power output of the system to be 9.4 kilowatts, which is likely to power 29 average Pakistani homes. This project has successfully achieved our aim to design a working low-head hydropower converter to make use of the unused energy potential in the irrigation drop structures. This is hoped to be implemented in the specific site in Peshawar as well as other sites in Pakistan and around the world.